we're going to talk about solving quadratics. In this case, what they've done is they've told us that f of x, so the function notation version of a quadratic, the f of x is equal to 15. In other words, this equation here, x squared minus 6x plus 8 is actually equal to 15. So think of it as they've told us f of x is 15, so we can replace the concept of f of x with the number 15. Just like if this was y is equal to 15, and this was y, we would replace it with 15. So in my next line, I can write 15 is equal to x squared minus 6x plus 8. Now, how do I find out which of these x's or what value of x gives us 15? It's a quadratic. I mean, there could be 1, 2, or no answers to this. And the reason I tell you something like that is, and I'm going to allude to the process here, is with quadratics, you can have no roots. That means no places where it catches an x-intercept. So in other words, that's no answers. You can have it where a quadratic just touches, okay, where a vertex is on an x-intercept. That's one answer. Or you can have something like this where it crosses it twice and you have two answers. Okay, so really interesting. Starting to show you the different types of ways you can get to this. You notice I alluded to x-intercepts. That's actually really important to this process here. What we're going to do is try to set up a scenario where we're solving for the roots or the x-intercepts. And in order for that to be true, an x-intercept exists when the y value is 0. In this case, the y value is 15. But what we can do is we can manipulate the equation. Let's move 15 to the other side. When we do that, think of it as if we're just subtracting both sides of the equation by the number 15, okay? So when we do that on the left side of the equation, we have 0 is equal to x squared minus 6x plus 8 minus 15. Now we have, when we simplify 0 is equal to x squared minus 6x minus 7. This is a quadratic that is set equal to 0, which means we can find the roots. And those roots are going to be the answer or the x values that allow this specific equation, when substituted into x, to equal 15. Now these trinomials, when finding roots, we usually try to turn things into factored form. Factored form graphically helps us find what roots are. And when we do that, if you recall, we want to go through the process of factoring. Now, this is kind of a product in sum one. You can use decomposition and go through it. This is a really quick one. Because the a value is just 1, I can go right into a factored form. I can say 0 is equal to, in my set of brackets, I just need two values that multiply to a times c, and because a is 1, it's just the c value, negative 7. And those same two values are equal to the b value, which happens to be negative 6, okay? And because it's an a value of 1, I don't have to go through the decomposition, then common factoring, and then factoring those groups. I can just jump right to the final form here. These two values, they're going to be the second term, and my first term in each bracket, I already know is just going to be the variable x. So, two numbers that multiply to negative 7. Well, negative 7 is a prime, so you really just got 1 and 7. We just got to figure out what scenario of 1 and 7 also equals negative 6. If the 1's negative, we don't get negative 6, so that means the 7 must be negative. And that means these are the two terms, positive 1 and negative 7 in factored form. So we have them in factored form. What this equation says is this is a term, okay? Let me put it here. Think of this as this is a term. We'll call it term A. And this is a term, term B. Term A times term B is equal to 0. We're going to use some general rules about mathematics and multiplication here. In order for anything to multiply to 0, one of the values you multiply by has to be 0. No other numbers give you a multiplication of 0. You have to have a 0 involved. So in other words, term A must be 0 or term B must be 0. So there's two potential answers here. And because of that, what we do now is we split the equation. We say that 0 is equal to the first set of brackets, which is x plus 1, or 0 is equal to the second set of brackets, term B, x minus 7. We isolate for x, so we move 1 to the other side. You get -1 is equal to x. And in this case, you get x is equal to +7. And what that means is we have some quadratic, and because the a value is positive, we know it opens up, where there's an x-intercept at -1 and another x-intercept at +7. So it does something like this graphically, okay? But more importantly, these two are our values of x that turn this equation into equaling 15. So let's test them out on the next page. We said f at x was equal to x squared minus 6x plus 8, I believe. And we were confident that the x values would be at f at -1 and f at +7. If that's true, let's try these out. F at -1 gives you, I'm going to put in red here just to show that substitution. -1 squared minus 6 times -1 plus 8. -1 squared is 1. This becomes +6 plus 8. 8 and 6 is 14 plus 1 is 15. Great, that worked out. Test our second answer. F at 7 gives us 7 squared minus 6 times 7 plus 8. 7 squared is 49. 6 times 7 is 42, and it'll be a negative, plus 8. 49 subtract 42 is 7 plus 8 turns into 15. Amazing. Both of those worked out as answers, and we can verify something like this. Let's turn off all of the other equations I have here. I apologize. Should have made this a clean decimals page. There we go. Turn that one off. Let's type in the equation f at, let's say f at x is equal to x squared minus 6x plus 8. If we take a look, oh, I gotta get rid of those labels. They gotta be in the way. There you go. If we look at the roots, these are the answers. Oh, sorry, I apologize. The roots would be when f at x is equal to 0, but we want to know when it's equal to 15. Y equals, all right, y equals 15. Zoom out a little. Y is equal to 15 at -1 when the x value is -1 and +7, okay? So that's another way we can kind of check our answers for a question like this.